Okay, for the last example, all they've given us is an equation. So what I need to do is I need to go to my y equals table, and I need to graph 2 to the power of x plus 7. And then I'm only showing the first quadrant here, so I'm going to hit graph. And it looks like I need to do some window adjustments because I need to see more of this first quadrant here on my graph screen. So I'm going to go to window, and I'm going to take this down to negative, let's say 3. I'm going to leave it out to 10. And then I need to get some more y values because I don't quite go down to negative. So I'm going to say keep that at negative 3. And then I'm going to take this up to 24. And I'm going to count by 2s. I'm actually going to make that even, negative 2. Now I'm going to hit graph. So now I see a little bit more of my graph. So I know I'm counting by 1s on my x-axis. So I'm going to go ahead and label these by 1s. And my scale on the y-axis was 2. So I'm going to count by 2s going up the y-axis. And I'm making them very small so I don't take up a lot of space here on the side. Okay, and now I'm going to get some good ordered pairs. So I'm going to go to my table, and I can plot 0, 8. I can plot 1, 9. It's going to be right in between 8 and 10. And I can plot 2, 11. And 3, 15. Looks like all the even y values, which is nice because at least it fits right in between. Okay, and I'm going to go ahead and connect these because there's nothing telling me that I'm going to be skipping over or leaving out any x values. So I'm going to put an arrow because on my graph, if I had more coordinate plane showing, if I zoomed out, I would have more exponential graph shown. So it keeps going. There's nothing that tells me here that I need to stop at any point. And then it looks like it's flattening out. So I'm going to go to my table where the x's are negative, and I'm going to see what number it looks like it's flattening out to. And if I look here, it looks like it's getting closer and closer to 7. So what I'm going to do where 7 is, I'm going to go ahead and flatten this out here. And if I look for domain, because now I have a sketch in my paper that I can use to draw boundaries and borders if I need to. Now it looks like here I've got 2 x values. So I've got an arrow here, and then at this end it's going up and it's going to the right, but for domain I need the left and right arrows. Okay, so since I'm going all the way to the left and all the way to the right, I'm using every x value possible. This is all real numbers. I am not going to leave out any x values. If you wanted to write the double R for all real numbers, you certainly could use that. And now I want to find the range. And remember, range has to do with the y-axis, so we're going to be moving up and down, not left and right anymore. So I want to look and see how low. What are the lowest y values that I use? And that's where that flattening out of the graph is going to come in handy. So it flattens out to 7. So I'm going to draw a boundary line at 7, as straight as I can. And it's going to be y is greater than 7. And remember, it's not ever going to touch that line. So I need to put a no bar on this symbol. So it is going to say y is greater than 7. And then if I ask myself how far up the y-axis it goes, we have this arrow right here which tells me it doesn't stop going up, so my range is going to be y is greater than 7. So when they give you the equation, it's helpful if you graph your calculator. You may have to do some window adjustments to help you sketch the graph, but you just need to know or ask yourself, are they asking me to leave out any x values? Okay, if not, then your domain would be all real numbers.